Dan worden we welkom Dr. I missed your name for Carsten. Carsten is all the way from Hamburg to come and make a presentation here. He has a nice reputation in energy and renewable energy. He started his PhD with levelized cost assessments, and afterwards he was involved in one of the biggest wind turbine companies. Later on he switched to another company which built actually big wind farms in the North Sea. And now he has his own company since 2013 with Sunoyster. It's a very special concept. You the floor.
Yeah, thank you very much for inviting us to this beautiful city and to this nice hall. So my colleague Amelie and I will be happy to tell you a little bit about the Sunoyster. And maybe Amelie, you can already pass around some flyers now that we are waiting here for the login. And as you can see already from the flyers, we are working with mirrors as well. So Sunoyster Systems is a small company from Hamburg in Germany. And as Sietze said, we started in 2013 developing this technology, and we must say it's quite complex, so it takes quite some time to get it ready for the market. Yeah, the Sunoyster uses, just as Aztec, parabolic mirrors to concentrate the sunlight onto a line. And in that line is a receiver, which can, in our case, convert the energy either in heat or into electricity and heat at the same time. So to give you a little overview, we have heard the presentation from Aztec on parabolic troughs. So they are good for a temperature range or a delta T from say 100 degrees to 400 or even 500 degrees with molten salt. And below that is the range of the Sunoyster, which is going from roughly 50 degrees delta T to up to 170 degrees. So if an application, for example, a chemical plant needs 250 degrees, for example, it would be well possible to combine the Sunoyster for the lower temperature range and then the big parabolic trough for the higher temperature range. Above the parabolic mirrors are the solar towers going up to 800 or 1000 degrees. And below are the vacuum tubes and the flat plate collectors, as well as the swimming pool collectors, generating just some degrees of delta T, but that very cheaply. Yeah, the Sunoyster is trying to combine the best aspects from existing solar technologies. There is on one hand CSP or CST, where we use the cheap mirrors as well as the glass insulation of the receivers. There is on the other hand CPV, and there we have in common the biaxial tracking, that we are following the sun all day. and also the high quality concentrator cells in our hybrid receiver. And finally, there is PV, where we join the modular design, starting from small power outputs. And we can also be installed on the roof, just as PV, which is a good place for solar energy because the roof is not used for other things normally, and it's relatively free of shadow normally. And of course, we want to match PV in cost efficiency. So the Sunoyster follows the sun all day in two directions. So in addition to the elevation, it's also tracking the sun from east to west. That is needed, so to say, for our short trough. In contrast to the big parabolic troughs, we would otherwise have, with such a short trough, big end losses in the morning and in the evening. And that is why such a small system, so to say, has to track also from east to west. And another speciality of the Sunoyster is that it closes down when there is too much wind, just as Axe Solar. That is possible because the Sunoyster is using from the full parabola only 1/2, and therefore it can go into this flat safety position. And that is obviously where the name comes from, so it closes just as an oyster closes its shell in case of danger. So coming to the receivers, there is on one hand our hybrid receiver, which is patented in Europe and in China. And it has a secondary concentration with the help of glass lenses, focusing on very high quality concentrator cells with an electric efficiency of up to 44%. Amelie has one example there. It's only a short piece instead of the 4 meters and a bit heavier than the normal system because of 2 compensators and a thicker glass. So from serial production, we want to reach a total efficiency of 75% with that receiver, 30% electric efficiency, and 45% thermal efficiency. However, we must admit that we are not yet fully there, so there still needs to be a little bit of optimization done with that hybrid receiver. And the other one is the normal CSP receiver, which is a little bit downsized for our small system. And the one which has just been certified comes also from Huyin, one of the partners of Aztec. So we just received the Solar Key Mark certificate, which shows that the system has now reached maturity and the performance is measured. That allows us also to receive grants, or our customers can receive grants in many European countries. Here is the example of Germany. So for solar heating, it is 30 to 45% of the total system cost. For process heat applications, it's even 45 to 55%. And soon there will be a scheme for networks, district heating, with 40% plus 2 euro cents for solar heat. So their German government is expecting to give an incentive for 400 megawatts of heat networks every year. Our Sunoyster has 16 square meters of gross mirror surface, and in both cases, for the hybrid receiver as well as the thermal receiver, this corresponds to roughly 16 horsepower. Quite easy to remember. We think that when all countries are now going for climate neutrality, until 2050 at latest, space becomes very important. So basically every building has to become climate neutral itself, and then space will be very precious. And with the Sunoyster we can use the space which we need for tracking anyhow for some additional PV modules, and then we generate in most climates roughly twice as much total energy on the same surface as our strong competitor PV. And in sunny locations, this is the example of southern Spain, it would even be 2.5 times the total energy of PV on the same roof surface. So that means the solar coverage of a building which has maybe 20% with PV, a hotel with PV, 20%, the Sunoyster can then contribute roughly 50% of that total energy demand. So with that high efficiency, we can basically cover the complete energy demand of buildings, not only powering the house, but there is some electricity left for the electric vehicles, sanitary warm water, in winter heating. In summer the heat can also be converted into cold, and in spring and in autumn there's maybe even also some heat left for the swimming pool in southern regions. There are manifold heat applications in our temperature range from 0 to 170 degrees. So besides sanitary warm water and heating, it is also process heat or desalination, which will become very important in the next decades, or cooling. Looking at the economics, with the present price of the Sunoyster, which is still from a small scale manufacturing and not yet a large serial production, the system is already pretty attractive. So with a 30% grant in Germany and a loan on the investment, the payback time on equity is roughly 1.5 years, and the profitability is around 25%. For those people who do not need any heat at all, we now want to use our tracking know-how also for a small PV tracker. Compared to products which are already on the market, we want to be a bit smaller, so less than 3 meters. And that means that there is no building permit needed in Germany at all. Also price-wise, with a smart foundation and logistics concept, we want to be very attractive, so that this system can be well cheaper than a system mounted on a tilted roof, because we don't need any scaffolding and installation is easier and faster. Plus you have roughly 30% more energy yield than a fixed module which is southward looking. And quite soon in October we want to install the prototype of our new Sunoyster 8, which is pretty similar to the Sunoyster 16, but shall make another step forward, being lighter, easier to install, and more flexible, because it can also be installed on tilted roofs or any kind of tilted surfaces. And this Sunoyster 8 shall also come in 2 versions, just with a heat generation or with a hybrid receiver. And once again, additional PV modules can be added. Yeah, it shall be relatively stylish, and for Russia and the Gulf region we are, for example, planning also a model gold, or we are flexible to make a Dutch model in any shape. So, And the backside of this versatile tool could be used for an LED, for publicity, for example, as it is anyhow moving 360 degrees. Yeah, so we would be very happy to do some projects here in the Netherlands, be it single machines or be it small small networks for Sonnewarmten. And yeah, thank you for your attention.
Thank you very much. Questions?
Questions, yeah. Anyone?
Do you have a solution for freezing in the winter of the water?
You mean so that the water in the system is not freezing? Yeah. So I mean, one solution is of course to use some anti-freezing chemicals such as glycol. That is our normal solution. We could also use silicone oils if, for example, the temperature range is going towards the 170 degrees. But we do not offer any drain-back system as, for example, Paradigma does. Mm-hmm.
Ja.
Ja.
Eén moment. Nee, geef hem die mij. Geef hem die microfoon aan. Ja.
Thank you. Interesting, very interesting technology. I guess that your system seems to be more focused on small-scale projects, individual housing, and not so much on providing heat for large-scale heat networks. Is that right?
Well, I mean, it's a modular system. So our new Sunoyster 8 can start from single homes, whereas the 16 is a bit too large for a normal single home. Yeah. But the 8 is suitable for single homes. But just as PV modules, it's basically modular. So it can also do larger projects, which so far we have not yet done. But we are open to, and then we have to combine it, and it is clear that we have then slightly higher heat losses on the way from one receiver to the next than your system, where the receivers are directly neighboring.
Yeah.
Yeah.
Do you mind if I ask one more question? I have the microphone now, so I may as well. What kind of heat price are you looking at in terms of euros per megawatt hour? Kind of a ballpark figure or a range?
Mm. Yeah. So we want to match the low prices of the large systems in Denmark. So say 30-40 euros per megawatt hour. In our climate, of course, if you're going to Atacama Desert in Chile, it's becoming less.
Yes. It's a pity that you did not do your presentation in German, because this well-educated audience would, without doubt, have understood you perfectly well. But well, I understand from your presentation that it is more cost-effective than PV, your project. And well, I think your final remark was, I hope we can do some projects in the Netherlands. It's a nice wishful thinking, but when it is more effective than PV, I think, is there any action? PV, people who want to put PV on their roof get subsidies, get money from the state. Do you apply for that? And with the argument, when you give money to PV, the ineffective PV, then we demand, for the sake of the climate, that you subsidize this project. It should be a bit more aggressive, because it is a better technique. It should prevail. So, not as a final sentence, we hope to do some projects in the Netherlands, and then pray that it will come from itself. But, well, there should be a more aggressive presentation.
Maybe they need you.
Yeah, thank you for your question. So I would not underestimate PV. I mean, PV has done a wonderful job in bringing the cost of electricity down. It's more than factor 10 over decades, and it's not easy to beat. And I mean, not by chance, we are offering on one hand the solution PV Plus, and soon also the PV Mover. So PV is really good, and you must be strong to beat it also economically. Yeah, I mean, I have one slide where I'm showing that our target price for the hybrid receiver is 670 euros per kilowatt, whereas for a small scale system, whereas for PV the market price in Germany was recently 1,000 euro per kilowatt, including substructure and inverters. So yes, we are trying to beat it from the serial production, but this serial production is not yet there. And so sometimes one has to be careful with the claims.
One moment, please. There's a question here.
Yeah, yes, I would like to add something to a question that was asked just recently about the why don't we win this battle? Okay, now I'm a bit well, I'm a board member of this organization, so you know I have an opinion. But we are 3 times more efficient than other sun technologies. All right, and we want to get rid of oil and gas, and we still can't win this battle. That's why I am in this board now, okay? So, 2 speakers this afternoon have suggested that there's a problem somewhere in the supply chain, yeah, die toeleverketten, yeah? There's some problem there. What's the problem? Where do we go wrong? Tell us.
Yeah, of course, supply chain is important. I mean, PV is coming from these huge gigawatt factories in China. And if we look at the supply chain for the mirrors, some years ago, our pre-series machine ordered those mirrors from the Bavarian forest in southern Germany, Flabeck, but then they went bust, and so now we have still, I think, one larger mirror supplier left in Europe, which is Rio Glass in Spain. And China, on the contrary, has a pretty strong supply chain also in this field. So right now we are buying our mirrors from China. But still, the quantities of these mirror productions are pretty small compared to the PV modules, and that gives a certain disadvantage in the supply chain, which can be compensated or by larger numbers. So we must try to bring the numbers up, and then also the supply chain will become stronger. It's a cycle, a circle.
Thank you for your presentation. My name is Erik Karton. I think that one of the problems that we have here is that you make heat, and everybody has electricity at home, and so you can easily plug in your PV and share that. But you cannot do that with heat. You have a local heat source. And the other problem is that you have your demand mainly in the winter and you generate the heat in the summer. So where's your solution for the storage? I missed this. I have to wait 6 months before I can use the heat. So what do I do in these 6 months?
So indeed, the seasonality here is an issue. There are climates in the world where your solar resource fits better to the demand, but here we have this phenomenon that we have very good sunshine in summer, but we need the heat in winter. One solution to that are large earth ponds, I think, as they are practiced in Denmark. Dig a large hole, make it only waterproof to the ground, no insulation needed. Put an insulation on top, and you can heat it up to 80 degrees and can heat with that energy in winter as well. On the small scale, this is so far still a bit difficult because not everybody wants to have a 10-meter high steel tank in the center of his house and make some stairs around this tank in order to make it look nice. There is some hope that soon there will be kind of heat batteries, a chemical storage of heat in form of metal hydrides, which has a 10 times the storage density of warm water. And then your seasonal heat storage can be as small as the former oil tanks and can work for single-family homes. But unfortunately, so far they are not yet ready for the market.
Hi, my name is Dang, and I want to add to the previous questions. We are mainly focusing on heating for houses or making our houses more sustainable. But what about the industry? Why isn't this used for the industry? Because they are the most, the ones the most using the fossil fuels and are more polluting. Why don't we use this system for the industry?
Yeah, I mean, one reason is sometimes the temperature level. So some industries need more than 170 degrees we can supply. Then one has to go for larger parabolic troughs. And another reason is, of course, cost. I mean, the CO2 tax has only just started. If I understood correctly, also in the Netherlands, it has just started. In Germany, it has just started. So the prices of fossil fuels are not yet speaking the truth. Fossil fuels are still too cheap. And therefore, solar heat has difficulties to compete with a kilowatt hour from gas, which costs only 1.5 euro cents or so. When the CO2 tax has a larger impact, it will be much easier for solar systems to compete also for a large paper industry or a chemical plant.